All right, so our first one, we're talking about a recent dramatic drop of 500 points in Dow Jones Industrial Average. We've got a poll, and they found that 92% of those polls said that a year from now their family financial situation will be as good as it is today or better. Which of the following describes the number 92? Is it a statistic, sample parameter, population parameter, or population? I don't know about a sample parameter. I think that one is there to throw you off. Yeah, it is a statistic. It is. Yes. It is right? It's a p hat, right? It's p hat. It's a sample proportion. Cool. Yeah? All right. Any questions about that? Okay. All right. What is distribution? I think this was picked by a Russian. What is distribution of values?
The distribution of values.
Values. Is distribution. Taken by a statistic in all possible samples of the same size for the same population. Oh, sorry. There was a question on your take-home quiz like this, where it said, "Hey, remember it said she gave you that distribution of 200 sample means, and it said, hey, is this the sampling distribution of all mean lengths?" And you were supposed to say no. Or what it was it? Sorry, what is this the sampling distribution? You're supposed to say no, because it wasn't all possible mean length. So then the answer is D, right? D. Yeah. All right. Hey, if a statistic is used to estimate a parameter, it's such that the mean of its sampling distribution is equal to the true value of the parameter being estimated. What is that statistic said to be? It is unbiased. It is an unbiased estimator. Right? Nice. Yeah, I don't know. I hate it when people read to me, but I'm reading to you. All right. Suppose that you take a random sample of size 25 from a population. Let's see. We've got a mean of 120. Oh, shoot. All right. So we took a sample. So N is 25. All right. Which is 30 base for 3. All right, let's see what's going on here. So our sample mean
Yeah, isn't it gonna be that one
All right, so the distribution of the population, not, right? Because the standard deviation of the population is 15. So that one's out, right? The distribution of the sample data, we don't even talk about that. Sample mean, I like a lot. What is, of course we would have to check the condition, but I'm just working a multiple choice question, so I just want to see what this standard deviation is if I work it out. Yeah, 15 over, okay. It's not a population. Yeah, it's not the population mean, right? We've been given a lot of information. I'm going to go with C. All right. Okay. I think this one's kind of big. All right. In order to use this formula to calculate a standard deviation, what's got to be met? Okay, so let's talk about it. This is talking about the central limit theorem, right? Which doesn't tell us whether we can use this calculation for standard deviation. It's telling us if we can assume that the distribution is approximately normal. We don't really need, in order to use a different calculation for standard deviation, we don't need to know that it's normal, right? All we gotta know is this, right? That's all we need. Now, if we're gonna perform a normal calculation, we will need either one or two, right? It's either gonna have to tell us that the population distribution is approximately normal, or it'd be good enough for our sample size to be greater than 30, right? But in the case of just making this calculation of standard deviation, that works, all right? Okay. Central limit theorem. What's going on? Which one? Oh my goodness. Whew. This one's wordy. Okay. Regardless of the shape of the population's distribution, the sampling distribution of the sample mean from sufficiently large samples will be approximately normally distributed. Well, I like that a lot. Let's see. Regardless of the shape of the population, the standard deviation, no, right? That's not what central limit theorem is telling us. Okay. Regardless of the shape of the population distribution, the mean of the sampling distribution of the sample mean from sufficient, no, right? Central limit theorem is telling us that if your sample size is large enough, you can assume that the distribution is approximately normal. As you take larger and larger samples from a normally distributed population, standard deviation, no. As you take larger and larger samples from a normally distributed population, the mean of the sampling distribution gets closer and closer to the population mean. It's pretty close. So this E is your distractor, right? But the answer is A. But be careful, E is your distractor, because it's a true statement, right? And a very useful thing to know, right? Yeah. Yeah. So there we go. All right, caught that one. All right, let's see here. An SRS of 1,000 Americans said they were 62% said that found that 62% satisfied with the service provided by the dealer from which they bought their car. Let's see, we got an SRS of 1,000 Canadians. So we got 2 samples, 59%. Okay. Whew. Oh, that's kind of nasty. All right. Sampling variability associated with these. So they're the same size, right? All right. Exactly the same, possibly. Not exactly the same, very close. Much smaller. Is the population of Canada smaller? Smaller for the sample of Canadians because the percent satisfied with smaller. Out. Okay. Larger because Canadian citizens are widely distributed. Yeah, so that's out. I'm trying to determine, does the population of Canada affect the variability of the sample? Probably not. So between A and B. Are they exactly the same? There's no way they could be exactly the same, right? So then I'll choose B. Sometimes you just gotta deduce. Right? Sometimes that's just what you gotta do. Alright. A student is investigating some study habits. So we have an actual parameter. The mean number of minutes they spent on their English homework, 45 minutes, with a standard deviation of 15 minutes. Which of the following was surprised what we know about the sampling distribution of means. Well, 16 students is not enough to assume that it's normal. So right away, approximately normal, out. All right. The standard deviation can be 15, right? Yeah, it's got to be, yeah. So, should be E? Yeah. And we're able to take this one out because that's not correct. We know what this is, right? Cool? Not bad. Alright. Okay. Olive weight. A colossal olive, right? Ooh, what is the probability that a random sample of 3 olives from this population is greater than 8 grams? Yeah. So we've got to decide. Are we looking at a proportion or a sample mean? We haven't been given any sort of proportions, right? There are no proportions in this. Huh? So, right? These standard deviations down here represent standard deviations of the sample proportions, okay? These three standard deviations look at standard deviations for our sample mean. So, which one's right? Yeah, it's A, right? So you have your X value, because that's what we're looking for, minus your mean. The standard deviation is correct. This one's backwards, right? And this one, we wanted to know if it was greater, right? And this is a Z, sorry. That's a Z, it's hard to see, right? This one's in the wrong direction. Cool. I liked that a lot of you guys on your practice quiz were actually writing this exact thing when you were performing your calculations. It's pretty good. I think this is the last one. Yep. All right, and we've got another one. A large population. I hope it's sufficiently large. We've got 46% of our households with DVD recorders. Wow, it's been a long time since DVD recorders were a thing, huh? That more than half of the household. So then, we've been given a proportion right here, and we're checking another proportion here, right? So then this is technically our X, right? Yeah. And we're looking for greater than, right? So we're looking for Z greater than. So anything that says less than is out. Just that one, right? And we should have, it should be in this order, right? Even though that's out. Huh? C's not good. Well, I don't even understand what the standard deviation over here for C is doing. I don't get what's going on here. Yeah. Five, 4.
You have to do 1 minus 4,
Yes. That's right. So it's got to be E. Why is this one out? Because they're using
0.5.
Yeah, that's not what P is, right? P is not 0.5. P hat is 0.5. All right. So we chose E. Fantastic. That's your multiple choice practice for Chapter 7.